learning machine learning today, there's a good chance you'll spend the next 6 months jumping from Python tutorials, AI courses, AI tools, math courses, random machine learning projects, only to realize that you don't still know what to learn next. But if you follow this roadmap from the beginning, 6 months from now, you could have the foundation needed to start building real machine learning projects. So what does that roadmap actually look like, and what should you learn first, second, and third? So in this video, I will show you the 9 essential building blocks every machine learning engineer should master, and the other you should learn them in.
The first pillar on the roadmap is Python. If your goal is machine learning, Python is where you should begin. Why? Because almost every major machine learning library and framework is built around Python. The good news is that learning Python isn't as difficult as many people think. With consistent practice, you can build a solid foundation in about 3 months. Using free sources like YouTube or W3 School, focus on mastering the fundamentals first. Learn variables, data type, functional statements, loop, functions, object-oriented programming, file handling, exceptional handling, modulars, modules, packages, and virtual environments. Once you're comfortable with those, learning machine learning libraries becomes much easier.
Once you have built a solid foundation in Python, the next pillar is data structures and algorithms. Many people skip this step because it doesn't look like machine learning. That's exactly why most beginners struggle with it.
Data structures teach you how to organize data efficiently, while algorithms teach you how to solve problems efficiently. You learn about arrays, linked lists, queues, trees, graphs, tables, sorting algorithms, searching algorithms, recursion, and the big zero notation.
Think of it this way. Python teaches you how to write code. Data structures teaches you how to write code better. Once you can write on and understand how to solve problems with code, the next thing you need is Git. Think about it this way. Writing code is one, but managing your code is another. As your projects become larger, you will make changes, experiment with new ideas, break things, fix them, and sometimes need to go back to the earlier version. Without a version control system, keeping track of changes can quickly become messy. And that's where Git comes.
Git allows you to track changes, create different branches, return to previous versions, and manage your code efficiently. You want to understand essential commands and concepts like init, clone, add, commit, push, pull branches, merging, and resolving conflicts.
And here's the important part. You don't have to be a Git expert before moving on. You just need enough Git knowledge to confidently manage your machine learning projects and work with other developers. Once you have the foundation, you're ready for the major part of the roadmap, which is SQL.
With SQL, you will learn how to retrieve, filter, sort, join, and summarize data using commands like select, group by, order by, and join. Before you can build an intelligence model, you first need to know how to find right data.
Now here's the part that scares a lot of beginners: mathematics and statistics. The good news is that you don't have to become a mathematician before learning machine learning. You do need to understand the concept and make machine learning work.
Focus on topics like linear algebra, probability, statistics, calculus, and optimization. Also, you'll also want to understand the concepts such as mean, median, standard deviation, probability, distribution, and hypothesis testing. Think of it this way: Python helps you to build machine learning models. Mathematics help you to understand why those models work.
Once you understand math, it's time to work with data.
Here's the reality. Real-world data is messy. It contains missing value, duplicate records, incorrect formats, and sometimes completely irrelevant information. Before you can train a good model, you need to know how to clean, transform, and explore your data. Learn tools like NumPy and Pandas. Practice data cleaning, perform exploratory data analysis, visualize the data, and engineer meaningful features. Remember, a good model trained on bad data will still produce bad results.
Fundamentals.
Now here comes the exciting part, machine learning itself. This is where you learn how machines recognize patterns and make predictions.
Start with the fundamentals: supervised learning, unsupervised learning, regression, classification, cluster decision, decision tree, random forest, support vector machines, and model evaluation techniques.
Don't make the mistake of memorizing algorithms.
Instead, focus on understanding when to use each one and why. Knowing machine learning algorithms is one thing. Building real-world solutions is another. Model development is where everything starts coming together.
You'll learn how to prepare datasets, split data into training and test sets, select features, train models, tune hyperparameters, evaluate model performance, save trained models, and build complete machine learning pipelines.
This is the stage where you stop following tutorials and start creating projects that solve real problems. The final skill is advanced concepts. Once you have mastered the fundamentals, it's time to level up.
Explore deep learning, neural network, convolutional neural network, recurrent neural network, transformers, large language model, transfer learning, MLOps, Docker, cloud development, APIs, and model serving.
Do not feel pressured to learn everything at once. Even experienced machine learning engineers continue learning as new technologies emerge. The important thing is to build a strong foundation first. Once you have that, every advanced topic becomes much easier to understand, and that's the complete roadmap to becoming a machine learning engineer. Follow these nine skills in order. Stay consistent, build projects as you learn, and you'll be far ahead of most who jump from tutorial to tutorial without a clear plan. So if you like this video, ensure you subscribe, like the video, and drop what you feel in the comment section.